Warm welcome to you all. A welcome to our Inventors Night tonight, where you get to meet the very inventors and makers here live at MotionLab.Berlin. For those of you that do not know, MotionLab.Berlin is a place in which you can realize your ideas and generate them and go from series or all the way to series production. This includes fantastic and authentic ideas that you will see from David, Will, and Suchi tonight. So, we're going to kick right off and go straight into our very first invention, which is brought to you by Heatel, and David will be representing them here tonight. So please welcome David.
Hi, thank you. Hi, I'm David Riding, and I'm a hardware engineer, designer, and I've got a background in avionics and product design. So what I'm going to show you today is one of my side projects that I'm working on, and it's called Heatel. That's quite a new name for it. We didn't know what to call it in the beginning, and it's basically a device that's designed to heat any liquid. Primarily, it'd be used to heat water, and what we're trying to achieve with this is deal with the huge global problem to do with energy usage and the need to live more sustainably. And one of the biggest offenders in any household, home or office is actually the electric kettle. No clicker. Yep. So, we're on. Technology. So, the thing about kettles is they waste a lot of energy. They consume somewhere between 2,000 and 300 watts, and that's quite a large problem because a kettle, by design, is actually a very efficient thing. But when you look at it as a system and something that's bought cheaply, it actually overboils, and it's lazy to turn off, and people overfill it. The kettle often gets dirty. So with that in mind, I try to design something that's actually a lot more efficient. So we tried to design an alternative which is easy to use, and so there's two ways of looking at this. With heat and liquid, you can use a kettle, you can use a gas burner, you can use a microwave. And what I've designed is actually a technology that's supposed to make that easier. And I think that's what technology is about. It's about making our lives easier. You know, we could wash our dishes by hand, but we use a dishwasher, which is a lot more complicated and a bit more expensive. But it's designed to make our lives simpler and easier on a daily basis. So what I tried to do was use any vessel. So it could be a cup, a carafe, a teapot, whatever. It can be used by anybody. It's portable. So there's a lot of heaters out there. There's a lot of induction cookers. But what we've tried to do is create a new category of a portable heater within the larger cookers category. So I experimented with lots of different ideas. I started with a very early prototype, which is a lot of wires and a lot of hacking, a lot of hot glue. And I experimented with charging phones. I went on to a second revision where I made a PCB, which is this shape. And now I'm on to this shape here, which fits into the device that I'm going to demo today. So we're helped by a few companies, including Schott, Vert Electronic, and Bosch Siemens Hausgeräte. So we did a lot of testing with this. You know, you come up with a hypothesis, you test it, and we tried to make it a scientific process. So we actually purchased every kettle we could in the market, and we did a lot of testing. And one of the important questions we was often asked is, what is the efficiency of our device? Because basically what we're trying to do is take energy from the grid and put it into water. So we had to really understand what water was, what its characteristics are. For example, the specific heat capacity. You know, how much energy is required to raise it over a certain delta, a certain temperature in a certain time. So with that in mind, we actually tested a lot of these electric kettles, and we saw that they were around somewhere between 50 and 60% efficient, which is a huge problem because this energy is being wasted every day globally. So we've gone through these stages of trying to make a bit of an ecosystem out of this with the accessories, the data, an opt-in service, where we can actually really log what's happening in the device. So there's some more investment slides that are in this standard pitch deck, which I'm going to focus more on the technology and the hardware. There's been some awards. We was at a few trade shows recently, including IFA. This is the team. There's actually 4 of us in this. So on the left there's Lana, who does the industrial design. There's Vaktan, who's the real grease in the machine that actually makes things happen in the business. It's myself. And Zenil, who's come in and takes care of really assisting Vaktan. Okay, so what I have here is a few things on the table. We've got different 3D prints. We're at kind of 3D print stage. And just to talk a bit about the product design process, when you have an idea, you need to, and if you want to get this thing manufactured, you need to go through a few steps. And there's a kind of demonstrator phase that you'll go through where you just try and demonstrate the concept of your idea. And that could be made in any way, wires, evaluation boards, off-the-shelf products, whatever. And then you get to a stage where you need to actually prototype this thing. And to actually prototype it, you generally need to, if it's an electronic device, make a PCB, maybe 3D print some housing, and really prove this prototype. But then there's a phase which I call the post-prototype, where you've made 1 or 2, you've made maybe 5, and they're 3D printed, they're expensive. That's where you'll make somewhere between 25 and 100. And if you do that, you need to really test this product on real users, and ideally collect this usage information, the data, and really get an idea of how people interact with this thing. And that allows you to make some changes before you go to mass production. So using that information, you can iterate your design and go on to a post-prototype stage. And then through that, you can go through to manufacturing. And that would typically be somewhere like 100 plus up to 1,000. And again, you test this product in a device, and you try and extend this testing phase as long as possible so that you can further prove your device as being reliable and function properly. And after that, you can look at the quantities, 10,000, 100,000. When it comes to pricing and costing these things, that's like a key topic. How much is this thing going to cost? Basically, the rule of thumb with electronic components is the price really drops. The knee is at 10,000 pieces. And 10,000 pieces and above, that's when you'll really see a price reduction of up to 60 to 70% in electronic components. And the same goes for the PCB. So this thing is actually designed to, with a lot of expensive components all sourced in Germany. But there would be, steps that you go through in the future where you try and reduce these costs, and you might custom make some of the components or resource them or something, anything like that. So if you can get to that phase, you're doing well, because it's very difficult to actually get right the way through to manufacturing. Other things you need to consider in manufacturing are things like provisioning your products. You have to provision this, you have to program it, you have to give each one of them a unique ID. And that's a really important process. So for us in this product, if you could just bring the camera down early, what we have is in this base is a miniaturized induction heater that actually has a coil in the center of this PCB. It's the first of its type in the world. Other people have tried to do it, and it's actually quite tricky. The concept of heating liquids actually really seems quite simple, but when you try and do it like this, with a disc that goes into a cup, you have to consider different cup sizes and geometries. Some of them have different diameters, different thicknesses in the base, and what that means is this disc that you're trying to target energy into, and that could be up to 2,000 watts, could be displaced left or right, front or back. It could be up or down, depending on the thickness of the cup. It could be in a thick fluid, like a milk or a hot chocolate. And when it actually starts heating, the disc moves around. And in power electronics, it's really important to actually drive at the resonant frequency, because that's the point where it's at maximum efficiency. If you deviate from that maximum efficiency, the device can actually fail. So it's very important to drive in the most efficient way so that your components remain cool and they're not hard switching, and all of these aspects have to be taken into account. So one of the cups I can use to demo this, just transparent glass, a thin base, just let me show you how this works. You just put the stick in. You can't see it on the camera, but there is actually a knob on the front, a rotary encoder, and a user interface. And using that, you can actually choose the temperature. You can put it in kids mode, where it recognizes the ID of the Bluetooth in the top and only heats to a maximum temperature. So potentially it's child safe. You can choose the temperature, and what happens next is this rod is receiving energy from the base. It uses energy harvesting to charge up 2 supercapacitors which are inside, and it switches on the Bluetooth. Now the Bluetooth is set up as a beacon, and it's sending its temperature back down to the base. Whilst that's running, the base is monitoring the temperature 4 times a second, and when it reaches temperature, it'll automatically shut off. And there is an app where you can use the thing if you want to. Most people don't like being stuck using an app, but it's nice to use an app sometimes to set up your preferences. If there's a large family using this thing, you can just load your preference easily, or you can set timers and things like that. So that's already boiling, and that's 250 milliliters of water. And water has a specific heat capacity of 4.186, and that means that we need to heat this from 20 to 80 degrees in 60 seconds. We need about 1.4 kilowatts, and this device is actually running at 2 kilowatts now. So I can heat up a cup of water in like 40 to 50 seconds, which is the fastest. And yeah, so I think that covers the technical side and the manufacturing. And a cup of tea. So I always demo this with water, but it could be used for all kinds of foodstuffs, steaming. Can be used for, like I said, milk, soups, things like that. So it's going to be a general device. And we're working on other concepts right now, like heating foods, perhaps a disposable carton where half of it's salad and half of it's, say, a curry, and you want to heat half of it. We can do those kinds of things on a device. So when it comes to using this thing, there's a lot of attraction of like calc and limescale on this. So we tried to make it user-friendly, so you can actually remove this disc off the bottom and you can put it into the dishwasher. So it's all magnetic, and then this thing stays out. I think that about covers it. I've shown you the 3 stages of the product development: the early prototype, the first PCB, and then this phase here. So we're going into the post-prototype, and we're currently dealing with companies in Berlin to make them in 100 quantities. And that's it.
Wow, thank you, David. That was very, very interesting, and it's always been a great pleasure to watch your journey here at Motion Lab, from where you've come to where you are now. And well, for me, it's been actually the first time that I've seen the heater in action, and it was very interesting to learn everything that you've managed. Now, next up, we have one of our key founders at Motion Lab in the sense of prototyping and manufacturing. His name is Will. And he has founded or designed something that goes more along the lines that I think every party should have. And he'll be sure to present it to you today. So please welcome on stage Will. Right.
Cool. Thanks, Taylor. All right, so my name is Will Fisher. I'm currently a freelance engineer here at Motion Lab. So I'm going to talk about some of my past projects because my current projects are under NDA, so I can't talk about those just yet. But to tell you a little bit about myself, I'm a mechanical engineer. I have a master's in mechanical engineering. I worked in that field for a number of years. While I was doing that, I went back and got my patent agent registration in the United States, where I was at the time. And then decided that maybe an MBA was a good idea, so I got one of those. And this is a project that I completed shortly before and then during my MBA, kind of to do the business on it, that I'll talk about. And the thing that you have noticed about this is that thing in the bottom where it says cocktail roboticist. Yeah, you read that right. We're going to talk about my adventures in cocktail robotics. So they started in 2014. San Francisco issued a broad call for the San Francisco Cocktail Robotics Grand Challenge. That was a competition. It started the first year with only 6 robots, ballooned up to 11, and we, several engineers that were my close friends, decided this would be a fantastic thing for us to go and compete in. So what do? We built a thing out of plywood. You can see the very early days of Inebriate, we called it. It was a spectacular failure. It had an electrical glitch that caused it to open all of its valves simultaneously, peeing liquid all over the tabletop, which was very entertaining. We got honorable mention because we made such terrible tasting cocktails that the judges couldn't finish them. We decided that was insulting, that was not for us, so we went along the next year, and in 2015 we came back with the first prize. This is Inebriate version 2.0, solid aluminum welded frame, 31 ingredients. It can mix a pretty mean cocktail. We went back in 2016, won again first prize. At that point, the coordinators of the event said, hey, this robot's too powerful. Now it has ice and stirring. It can call out names of people who are ordering, and you can order from your phone. Which was totally unnecessary but very fun. So we said, all right, what if we bring a new robot? Enter the Kamikaze Blaster. We changed the name feeling that Kamikaze, which was named after a shot, was maybe racially insensitive, so it became just the Blaster. And this is a truly innovative cocktail robot. What we realized from Inebriate is that it was a pain to set up, pain to clean, and not as fun to use. So we built something that is quite a delight. The video will play online. I'm sorry you guys can't see it for those of you who are in MotionLab. The way that it works is it uses a facial detection algorithm, an open source algorithm, to identify a face, fire a shot of alcohol up to 3 meters into the user's mouth, which now you guys are seeing looped and in slow motion. It's pretty impressive, it's startlingly accurate, and the user functionality of it is about 100%. Either it gets in your mouth, which is of course our doing, or you have a bad face and we missed. So that's definitely not our fault. But it's great fun and always a riot at parties. Thought to myself, gosh, I'm going to business school. What I should try to do is commercialize this, right? This seems like a great idea. Here we have a briefcase that has instant fun. So we created something that let us take photos and videos while people were getting shot in the face with liquor, which is as hilarious as you think it is. Unfortunately, seeing friends get shot in the face with liquor then become more hesitant rather than less hesitant. You think this is going to be a great idea and great fun until you're faced with the prospect of, do I want vodka on my coat? And the answer is most people shied away from it, which was really a bummer. And in order to try and get people to take shots of this thing, I ended up taking a lot of shots of alcohol. Fortunately, they're not full shots because you can't keep your mouth open long enough to get a stream of alcohol in it that is a full shot. So you take 12 shots to the face, and it's only like 3 drinks over the course of a night. It's not so bad. Plus, I was in business school. Another thing is we tried to use it for advertising. We went to large alcohol companies in the United States, and what we learned is there are a lot of crazy arcane rules around advertising alcohol. Anything that is conceived as fun, lawyers prevent, because then that would be advertising to children, and that's not okay. So here we have a super fun way of advertising alcohol, and immediately lawyers were like, no deal. So the takeaways you get from this are, one, you absolutely need to build a product that you love and enjoy and want to use, but you need to make sure it's a product that other people are interested in. And that was one of the big errors that we had in our design process. And the other major takeaway is that lawyers hate fun. This is just a fact. So the question is, hey, that was back in 2017. What have you been doing since? Well, I finished my MBA in June of 2019. And moved immediately to Berlin to start a startup called Wrinkle, making a smart bed desk hybrid. That closed down after about a year, and I took the remaining parts from it, and that turned into my bedroom. So you could see a stark resemblance between what didn't work and what now functions great as an actual bed. And now that company is closed down, I am freelancing and also looking for full-time work in the R&D and prototyping world. So if you need a prototype built, you can come find me at wfish.com. Thanks. Oh, that's good. Something.
All right, on that note, Will, I don't quite think we want to advertise you in such a way because we don't quite want to lose you from our community. So if you want to hire him, make sure he stays here. We do have some questions, I think, in the Q&A. Laura, is there anything that has been said? I think there's been a comment. How did you get the idea and what were the first steps? Hold on, we just need to disinfect 1 second. Let me just loop around you.
Okay, that's a great question. So the way that it originally happened is when we created Inebriate, the robot that came before the blaster, the giant one, we thought, hey, wouldn't it be cool if we took the app that we built for this and made it a commercial app where you could order your cocktails in a bar, and that way you didn't have to wait in line to get your drink. And we experimented around with a number of different URLs and app names for this, one of which was Drinkapult. And we got drinkapult.com. But the problem with Drinkapult is that nobody could spell it or figure out how to pronounce it. It was basically the worst app name of all time. And then we thought to ourselves, well, we paid $12 for this URL. Maybe we should build an actual drink catapult. And so we were sitting around playing card games one night, the same group of engineers, and figured, hey, why don't we just try to launch drinks into people's face with a catapult? And that, after we figured that Jell-O shots were not going to work super well for this, we decided the better way to do that was to use an actual stream of liquor, and the concept for the blaster was born. And so that's kind of how it came about. And then we tested it a great deal at my house in Oakland, including figuring out the range. At first, we realized we could have a much longer range than we have now, but if you pressurize the stream that far, it's quite uncomfortable to catch it. But we could pretty accurately hit a target 6-7 meters away, which is silly. Do you have more questions?
All right, I think that covers it. Thank you for your questions, and thank you for your time, Will. All right, next up, we have someone who is doing exactly this blinking robot at the back behind me here. Suchit has founded also a company this year in the name, or along with Imagine 2030. So I'm really keen to hear about his journey and how he got to the UMA. So please welcome on stage, Suchit.
Have your online shopping experience ever been a victim of bad delivery services? Mine was. Even after paying express delivery charges, what I got was a receipt that my parcel has either been delivered to a neighbor that who lives 2 blocks down the street, or to a packet shop which will be opened or which will be closed by the time I return from my work. And that's how I found out that the last mile delivery needs to be fixed. I'm Suchit Sharma, I'm a robotics engineer, and I took it as a mission to solve this problem. So I started researching what are the problems of delivery companies, and I found out that last mile delivery is the most difficult part of the delivery. It takes half of the time and 1/3 of the cost of the total delivery. Also, people are not at home in the normal 9 to 6 delivery times. Companies try to find alternate solutions like packet stations, which lead to further costs. The vehicles that they use, they run 60 to 80 kilometers per day in the city center, causing 7,000 kilograms of carbon dioxide per year, which is more than the own weight of the vehicle. And they consist of 30% of the traffic of the city, but they cause 80% of the congestion while finding parking lots everywhere. And electrification is super expensive. The employees, they have 3 minutes to deliver a parcel. They are super stressed, overworked, and underpaid, and that's why they also are prone to making more mistakes. And this whole process makes the whole last mile delivery super inefficient. So our solution to this is UMA, the last mile semi-autonomous delivery robot. Robotics have proved over the last decades to be more time and energy efficient and cost efficient in boring and repetitive tasks. Our robots have solar panels, which run them 50% of the time, so causing 0% emission and less congestion. They also offer extra flexibility, which means that you can order what you want and where you want just by a click of an app. So for example, imagine ordering a package at 11 o'clock in the night at your friend's address. And since we are a robotics company, but we are different, we are not taking away the jobs of the employees. We are putting them in a better position by offering them surveillance and driving job opportunities. So saying that semi-autonomous means that the robot runs most of the time by itself, but when it fails, people sitting in the call centers take over the robot and help it driving. And for this, we already have partnership with BWB, which is Center for Providing Employment to Disabled People. So this is our hardware prototyping journey. We started from the left side with 2 prototypes, a small and a big robot, and indoor navigation that we had built by ourselves in March. In the peak of Corona times, we did first outdoor delivery, which was totally controlled by human from a bakery in Berlin, which we think is the first delivery in Berlin by robots. Over the time, we built several design iterations, which was helped by me by my colleague Itan Rieger. In September, we did the first successful trial in an indoor campus environment in MotionLab area, where the robot could drive by itself from one point to another while doing obstacle avoidance. And over the last months, we made a new look on the robot. We installed solar panels and improved our navigation. And finally, we have this robot, which you also see here. It can drive by itself in a campus environment, which means a closed area, and it can do obstacle avoidance by itself. This is much for the pitch, but we also have already customer interest who are asking for our hardware, software, and different components of our technology. And we also did a pilot test last month. The pilot was indoors for helping an old woman, but the learnings that we did during these pilots are also used in the outdoor navigation to improve the outdoor navigation in a clustered environment. So finally, this is our product, UMA. If you like to see our demonstration videos, you can also go to the links and check it out. Our robot is driving around in the MotionLab area and maneuvering over cars, humans, and all sorts of things. And here is our prototype. We have a robot that can run 33 kilometers by itself, has solar panels, has 5 sensors. So it has LiDAR, camera, 3D camera, and ultrasonic sensors, bump sensors, and different things, so that when one sensor fails, it is taken over by other sensors. The robot can take 120 kilograms of weight and is super nice in the looks. Yeah, that's all from my side. So there are 2 more questions that are being unanswered. First one was, what was the most difficult part? I think the most difficult part as a hardware project was fundraising. And what did we learn? What is the biggest learning I learned was from an accelerator, a hardware accelerator. That is, if you have a hardware project, simplify it to the most simple one feature. Your vision can come over the time, but the most simple one feature that can bring value to your customers. And then slowly, when you start bringing this one feature into the market and start getting revenues, and then you also get easily more funding, and then you can roll on next features. And that was the one thing that I learned. Yeah, that's it. So I can repeat the question. Tyler says, what does innovation means to you? For me, innovation is making something possible that is not possible with the current technology. So building a technology that can make happen what is not happening today. And what's the second question? How does your innovation contribute to innovative future? 3 years ago when I started with this robot, so I started with a vision that robots should be in everyone's life and everywhere. When I started with this robot, most of the people were saying that it's very unrealistic. But over the 3 years, I have seen that there are a lot of startups coming up in Berlin, in Germany, and also in developing countries. And slowly people start to believe that the robots will be there, not in 10, 20 years, but maybe in next 2, 3 years in our houses, in everywhere around us. And I feel like with this product, I'm part of this revolution to bring the future today.
All right, thank you, Suchit. That was fantastic, and I've watched your journey too over the past few months, and it's been really, really enticing. For all of you that want to actually see this robot in action, check out those demo videos, and or head on to LinkedIn, I think. Oh, wait, Suchit's actually doing something right now. You don't see it, but I do. Will it move? Will it make a sound? I don't know. All right. It's not going to drive into me, is it? Oh. There we go. The UMA, ladies and gentlemen. Fantastic. Well, thank you all for joining us tonight. It's been a pleasure. We've learned a lot, and I hope to see you next time. For all of you that are interested in getting to know more about this space or see what innovations are currently happening, or if you have your own idea and wish to make it a reality, feel free to come to MotionLab. We'll happily give you a tour and show you around this place and see how you can best meet your ideas. Thank you all. Enjoy your evening, and all the best. Bye.